Let us now move on to the next very important aspect of speed maths, which is finding of squares. We know that square of a number x is nothing but the number x multiplied with itself. So x squared is nothing but x into x. It is very important that we find out square of the given numbers very quickly to avoid wastage of time in the exam. So in this part of the discussion, we shall see how to find out squares of the given numbers. If you want to be comfortable in finding out squares of any given number, you should be perfect with 1 to 30 squares. Generally, we are very comfortable with 1 to 10 or 1 to 15 squares. But as we go forward, for example, 27 squared or 28 squared, most of us get stuck. So make sure that it doesn't happen from next time onwards. For example, like how we know 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Same way, if I ask you what is 29 squared, you should not get struck. You should be immediately able to say that 29 squared is 841 or 27 squared is 729. So here you can see that 1 to 30 squares are written on the board. So remember all these values perfectly. You should not even waste a single second for any of these squares. The other point which I would like to mention here is how the units place of the square changes as the units place of the number changes. This point will be helpful in finding out square roots. For example, if you try to observe, whenever a number ends with 1, whenever we see that a number ends with 1, in all these cases, the square root ends with either 1 or 9. For example, here 1, square root of 1 is 1, square root of 81 is 9. So in both the cases you find that numbers are ending with 1. So whenever a number ends with 1, square root ends with either 1 or 9. Similarly in 121 and 361, you see that square root of 121 is ending in 1, square root of 361 is ending in 9. And square root of 441 ends with 1. Square root of 841 ends with 9. So very clearly, whenever a number ends with 1, its square root has to end with either 1 or 9. Likewise, if you observe 4, whenever a number ends with 4, in all these cases, the square root either ends with 2 or 8. For example, square root of 4 is 2. Square root of 64 is 8. Square root of 324 is 18. Square root of 484 is 22. That means if you observe, they are ending with 2 or they end with 8. So whenever a number ends with 2, its square root ends with 2 or 8. See, this pattern is very, very important in finding out square roots of the numbers. So you should be very clear with the pattern of unit spaces. Again, if you observe, when a number ends with 9, its square root ends with either 3 or 7. Likewise here as well, 169 and 289, square root ends with either 3 or 7. And in 27 and 23, numbers are ending in 9, their square root end with 3 or 7. The next one here is 6. When a number ends with 6, its square root ends with 4 or 6. Here again, numbers are ending in 6. If you observe, square root ends with 4 and here square root ends with 6. Likewise here also, when the number ends with 6, square root ends with 4 or 6. So very clearly, whenever a number ends with 6, its square root has to end with either 4 or 6. And the other point is, if the number ends with 5, square root ends with 5. Or we can observe that whenever a number ends with 25, square root ends with 5. And for zeros, it will be 0. Whenever we have 2 zeros, the square root ends with 1 0. Again here we have 2 zeros, the square root ends with 1 0. 2 zeros, the square root ends with 1 0. So very clearly we can understand the pattern of the unit spaces from this table. So make sure that you remember all the 30 squares perfectly and also remember the pattern. Whenever a number ends with 1, square root ends with 1 or 9. When a number ends with 4, square root ends with 2 or 8. When a number ends with 9, square root ends with 3 or 7. When a number ends with 6, square root ends with 4 or 6. When a number ends with 5, square root ends with 5. And whenever a number is ending in 0, even number of zeros, the square root will also end with 0. Assuming that you all remember what are 1 to 30 squares perfectly, let us now see how to find out squares beyond 30. For example, what is 63 square? Can you tell me the answer without writing anything on paper? And the time given to you is just 2 to 3 seconds. Now that might be a little difficult for you at this moment, but if you get the right idea, then getting 63 square or any square would become really very easy for us. So let's see how to find out squares after 30. For example, as I've said, let us find out 63 square. Now what we do here is, generally 63 square is taken as 63 into 63. And again, you know that if you go by the regular method of multiplication, that takes a lot of time. So let us see how to get it without going by the regular method. The point to be understood here is, for squares from 30 to 80, for all the numbers from 30 to 80, the base is considered as 50. For example, let's say we have to find out what is 65 square. Now 65 is between 30 and 80. So the base should be considered as 50 for 65. So 65 can be taken as 50 plus 15. That's how we break the number 65. Similarly, if you have to find out 72 square, 72 again is between 30 and 80. So 72 should be taken as 50 plus 22. Likewise, let's say we have to find out 41 square. 41 is between 30 and 80. So for 41 also, the base is 50. That means 41 should be taken as 50 minus 9. That means very clearly we can understand that for all the numbers ranging from 30 to 80, if you have to find out the square, the number should be taken as 50 plus x, where x can be a positive or a negative integer depending on the value there. So let us now understand how to find out 63 square based on the base of 50. 63, as you can see here, is between 30 and 80. So how do we split 63? It should be taken as 50 plus 13. Remember, it should be taken as 50 plus 13 but not 60 plus 3. Every number between 30 and 80 has to be taken as 50 plus x. So 63 here can be taken as 50 plus 13. Now let's understand how to actually find out the square for this number. We know that 50 square is 2500. So we take 25 and add 13 to this 25. That gives us 38. This is actually 2500 plus 1300, which is equal to 3800. And now the next step is to add 13 square to this result. 13 squared is 169. So the answer here will be 3969. 63 square is equal to 3969. I hope you all have got the idea. 63 should be taken as 50 plus 13. So 50 square is 2500. Whatever 13 we have here, those many hundreds have to be taken. So plus 1300. This gives us 3800. And the next step is add 13 square to this to get the answer. So 3800 plus 169 will be equal to 3969. Similarly, let's say we have to find out 72 square. 72 should be taken as 50 plus 22. So this can be taken as 2500 plus 2200. Whatever is the number here, those many hundreds have to be added. So this gives us 4700. And after getting this, we have to add this 22 square. 22 square is 484. So when we simplify this, we get 5184 as the answer. So 72 square is equal to 5184. So if you have really understood the concept here, we need not even write these zeros. We can simply understand that 72 is 50 plus 22. So 25 plus 22 is 47. So we write 47 and then 22 square is 484. As we have only two zeros after this, we have to take 484 in this format. That means 84 will be coming here and 4 will be carried forward to the hundreds place. So by adding this, we get 5184 as the answer. So this is how we can find out squares of numbers ranging from 30 to 80. Let's take one more example. Suppose we have to find out 42 square. Now 42 we know is 50 minus 8. So it should be taken as 2500. Remember, minus 8 will give us minus 800. Generally, if it is plus 22, we have added 2200. When it was plus 13, we have added 1300. Because here it is 50 minus 8, we take it as minus 800. So the result here will be 2500 minus 800 is 1700. Plus minus 8 square. Minus 8 square is nothing but 64. So when we add 64, we get the answer as 1764. That means 42 square will be equal to 1764. And again, if you really observe, you need not write these zeros and waste your time. We know that the base is 50, so always the first part here is 25. 25 minus 8 is 17. So we can write 17 and attach 64 to that. Why? Because 8 square is 64. So directly the square of this number is 1764. Similarly, let's say we have to find out 39 square. Now 39 is nothing but 50 minus 11. Remember, base is always 50. So 50 minus 11. So that is the reason we take it as 25 minus 11. 25 minus 11 is 14. So we get 14 in the first step. And then it was minus 11. So minus 11 square is 121. We know that there are only two places after this. Only two zeros after this. So 11 square 121 should be taken in this format. So the answer here will be 1251. 1521. 39 square will be equal to 1521. So this is how we can find out squares from 30 to 80 in just two steps. And if you really understand the method, even writing these two steps on paper is not required. Now before we move on to take some more examples, let us understand the working behind this procedure. Why does this happen? How can we directly get the answer as 25 plus 22, 47, and then 22 square 484 will give us the result of 5184. That means let us understand what actually happens behind this procedure in getting the correct answer. We know that a plus b whole squared, or a plus or minus b whole squared, is equal to a squared plus or minus 2ab plus b squared. Now the point here is, when we are taking 63 square, 63 can be split as 63 square can be split as 50 plus 13 whole square. Remember, we are taking the base as 50, so we get 50 plus 13 whole square. Now let's understand what is the advantage in this. If we try to expand as per the formula, we get 50 squared plus 2 into 50 into 13 plus 13 square. Now if you look at this, 50 square is 2500 plus 2 into 50 is 100, 100 into 13 is 1300, plus 13 square is 169. And now if you compare this expansion with our shortcut trick, you find that it is quite similar to what we have done in case of a plus b whole square. For example, here you see we have 2500, 2500, plus 1300, plus 1300. We get the result as 3800, and to that we add 169. That is the reason we are able to get the correct answer as 3969. This will be equal to 3969. Now the main advantage of taking one of the terms as 50 is that when we take 2ab part, we get 2 into 50 into b. 2 into 50 is always 100. So 100 into b will give us b into 100. So if it is 7 here, we'll have plus 700. If it is 8 here, we'll have plus 800. If it is plus 21 here, we'll have plus 2100. If it is 19 here, we'll have plus 1900. Likewise, here if it is 22, 50 plus 22, we'll get plus 2200. So that is the reason we have directly taken 2500. That's the first term, plus 2200. Even in this case, when we take 42 as 50 minus 8, it is 50 minus 8 whole square. So 2500 is there. Because it is minus 8, we'll get minus 800. So 2500 minus 800, 1700, plus 8 square, 64. So that is how we get the answer as 1764. So this is the concept behind finding out the square root in this manner. The two important advantages that we have here is, first term is always fixed. First term is always 2500, and the second term is b into 100, and the third term is b square. So because first term is fixed, we need not worry about it. Always you can take it as 2500, and the second term will be b into 100. Now if I ask you what is 69 square, you can do it orally. 69 is nothing but 50 plus 19. So as it is 50 plus 19, we take 2500 plus 1900. What is 2500 plus 1900? 4400. 4400 plus 19 square. 19 square is 361. So 4400 plus 361 will give us 4761. So that is the result for 69 square. Simply take it as 50 plus 19. 2500 plus 1900 plus 19 square. So 2500 plus 1900 plus 361 will give the total as 4761. Or if we have to find out what is 46 square, 46 is 50 minus 4. So we get 2500. Because it is minus 4, we have minus 400. 2500 minus 400 is 2100. Plus 4 square. 4 square is 16. So 2100 plus 16 will give us 2116. So this is how we can find out squares ranging from 30 to 80 in less than 3 seconds. Let us now understand how to find out squares for numbers beyond 80. We have already learned that for 30 to 80, always the base should be taken as 50. So how to get a square of a number which is more than 80? For example, let's say we have to find out 84 square. Let us understand what happens if we take 84 as 50 plus 34. We know that when we take a number as 50 plus x, the first term will be 2500, second term will be x into 100, and the third term is x squared. So here, when we take 50 plus 34, the first term is 2500, second term will be 3400. Because it is plus 34, we'll get 3400. And the third term here is 34 square. And that is what is the problem for us. We have no idea what 34 square is. Why? Because we know squares only up to 30. Now again, if we try to take 34 as 50 minus 16, the procedure becomes really lengthy. So the point here is, once we cross 80, the expansion will be 50 plus more than 30. And once a number is more than 30, the square is not known to us. So let us see how to find out for squares when the number crosses 80. Now the point to be understood here is, like from 30 to 80 we have taken the base as 50. So from 80 to 130, for squares from 80 to 130 you can take the base as 100. So let's see what happens when we take the base as 100. That means when we fix the first term as 100. So for any number from 80 to 130, it should be taken as 100 plus x or 100 minus x. For example, 84 squared. 84 squared can be taken as 100 minus 16 whole square. Generally we feel that 84 should be taken as 80 plus 4, but that is really very difficult when compared to this method. So always take it as 100 minus 16. Now if we try to expand this, we get the first term as a square, that is nothing but 100 square, minus 2 into 16 into 100, 2ab, plus b square, that is 16 square. Now if you look at this, the first term is 100 square. 100 square is nothing but 10,000, minus second term here, 2 into 16, 32, into 100, 3,200, plus the last term here is 16 square, which is 256. So 10,000 minus 3,200 is 6,800. 6,800 plus 256 is 7,056. That means 84 squared will be equal to 7056. So let us now understand how can we get the answer orally without writing all these steps here. The point is, if we take the number as 100 plus x or 100 minus x, no doubt the first term will be 100 squared, that is 10,000. So like in case of 50 we have 2,500 as the first term, here always we have 10,000 as the first term. The second term here will be 2 into a into b, that means 2 into 100 into 16 or 2 into 16 into 100. Now the point is, if this is 50, that means when the base is 50, 2 into 50 gives us 100. So that is the reason b into 100 is directly taken in the answer. But here we already have got one of the terms as 100. And if you look at the remaining part, it is 2 into 16, 32. So that is the reason 32 into 100, 3200 is taken here. So the point here is, whenever we take the base as 100, the other term should be doubled and then multiplied with 100. Like if it is 50 minus 16, we directly take it as minus 1600. But because it is 100 minus 16, we should take it as minus 3200. That means double of 1600. And the last term will be 16 square, that is 256. So very clearly, when the base is 100, the first term is 10,000. Second term will be 2 into b into 100. That means double the other number and multiply with 100. And the third term will be b square. Let us take a few more examples to understand this. Let's say we have to find out 92 squared. Now you know that 92 should be taken as 100 minus 8. So directly I can say that the first term is 10,000, which is always fixed. Because it is minus 8, we should take minus 1600. Remember, it should be double. Minus 8 into 2 is minus 16. So minus 1600 plus 8 square. Plus 8 square. So 10,000 minus 1600 is 8,400. 8,400 plus 8 square is 64. So this will be equal to 8,464. So this is what is 92 square. Likewise, if I want what is 97 square, 97 is 100 minus 3. You need not even write these steps on paper. Directly visualize the number of steps there. 97 is 100 minus 3. So 10,000 minus 600. 10,000 minus 600 is 9,400. 9,400 plus 3 square is 9,409. So the answer here will be 9409. Let's see what happens if we cross 100. For example, we have to find out what is 106 square, 106 square. Now here, 106 is nothing but 100 plus 6. So as per the expansion, first term is 10,000. Second term, because it is plus 6, we have to take double, plus 1200. So 10,000 plus 1200, that is 11,200, plus 6 square is 36. So the answer here will be 11,236. Likewise, I want what is 124 squared. Now this is really a large number, 124 square. But if you are comfortable with this technique, finding out 124 square will not take more than 3 to 4 seconds. 124 is 100 plus 24. So the first term is 10,000. Second term is double of b. That means 24 doubles becomes 48. So 10,000 plus 4,800. 10,000 plus 4,800 is 14,800. And the last term is 24 square. 24 square we know is 576. So 14,800 plus 576. That will be equal to 15,376. So this is how simple is finding out squares. So for numbers ranging from 80 to 130, always take the base as 100. Before we take some more examples from squares, let us quickly revise whatever we have learned so far. As I've already mentioned, for squares from 1 to 30, you have to remember them by heart. So make sure that you are perfect with the 1 to 30 squares, so that finding out squares more than 30 will become easy for us. Now, for any number ranging from 30 to 80, if you have to find out the square, we should always consider the base as 50. So that number becomes 50 plus x or 50 minus x whole square. So the first term will be 2500 plus or minus x into 100. So whatever x we have, that should be taken 100 times plus x square. And as I've already mentioned, writing even these steps is not required if you are comfortable with mental calculations. And for anything from 80 to 130, the base should be considered as 100. So that becomes 100 plus or minus x whole square. So the first term will be 10,000. Second term will be plus or minus 2x into 100 plus x square. And likewise, if you have to find out squares of numbers more than 130, what we can do there is consider the base as 150. So likewise, you just try to write 150 plus or minus x whole square and understand what will be the three terms. For example, 144 square. 144 square is beyond 130. So that should be taken as 150 minus 6 whole square. So again, the first term will be 150 square, that is 22,500 plus or minus. Here we will get 3x into 100 and plus x square. So the point here is, depending on the base, here the first and the second terms will be changing. For 50 we have 2500. For 100 we have 10,000. So for 150 we will have 22,500. For 50 it is x into 100. For 100, 2x into 100. So for 150 it will be 3x into 100. And last term always is x squared. So likewise, if you practice, finding out squares of any number beyond 130 can also become very easy. So either try to consider the base as 150, or then you can take it as 200, 250 and so on. Now the next point here is how to find out squares of numbers ending with 5. Now this is a special case where finding out squares of numbers ending with 5 is a very simple job. For example, we know that 5 squared is 25, 15 squared is 225, 25 squared is 625, 35 square will be equal to what? Now if you try to understand the pattern here, whenever a number ends with 5, its square always ends with 25. So if this number is ending with 5, we are sure that the answer should end with 25. So 35 square has to end with 25. The only concern is what is the remaining part of the answer. For example, here it's like 0, here we have 2, here we have 6. So how to get the remaining part of the answer in case of 35 square? So that can be understood as follows. If you look at this, the number here is 0, 5 whole square. So this tens place into the next higher integer. 0 into 1 is 0. If you go for 15, that's like 1 into the next integer. 1 into 2 is 2. So 2 into the next integer 3. 2 into 3 is 6. So that is the reason we get 6 to 5. So here it should be 3 into 4. 3 into 4 is 12. So the answer here is 1225. Likewise, if I want 45 square, 45 square is what? 4 into the next integer. 4 into 5, 20, 25. Or let's say we want 75 square. 75 square is 7 into 8, 56. So 5, 6, 2, 5. Or for that matter, we have to find out 125 square. 12 into 13. 12 into 13 is 156. So this becomes 15625. Or let's say 195 square. 19 into 20 is 380. So 380, and because the number is ending in 5, square ends with 25. So this is how we can find out squares of numbers ending with 5. If you observe properly, this is nothing but a case of multiplication of complementary numbers. For example, 35 square. We know that 35 square is nothing but 35 into 35. Now if you try to observe here, sum of the units places is 10. 5 plus 5 is 10. And the remaining part of the number is same. Here tens place is 3, here also it is 3. So these numbers are complementary. So we can find out the answer as 5 into 5, 25. That is, the first step is multiplication of units places. And second step is tens place into the next digit. 3 into 4, 12. So that is how we are able to find out squares of numbers ending with 5. Likewise, in case of, let's say, 65 square. 65 square is 65 into 65. Now if you observe again, these are complementary numbers. 5 plus 5 is 10 and tens places are equal. So these numbers are called complementary numbers. And the answer can be obtained as 5 into 5, 25, and 6 into the next digit, 42. So 65 square will be 4225. It is your turn now. On the screen here, you can find 6 questions which are nothing but squares of different numbers. And I believe 30 seconds should be more than enough to answer these 6 questions. And your time starts now. Time up, friends. I hope you all have got all the answers right. Let's see what the answers are. 57, 50 plus 7. So 2500 plus 700, 3200 plus 7 square, 49. So 3249. 71 is 50 plus 21. So 2500 plus 2100, 4600. 4600 plus 21 square is 441. 4600 plus 441 will be 5041. So this is 5041. 44 square, 50 minus 6 whole square. So 2500 minus 600, that is 1900. 1900 plus 6 square. 1900 plus 6 square is 1900 plus 36. So 1936. The next one here is 108 whole square. So that should be taken as 100 plus 8 whole square. So the first term is 10,000. Second term, as we know, is nothing but x into 2 into 100, or 2x into 100. So 8 into 2, 16 into 100, 1600. So 10,000 plus 1600 is 11,600. 11,600 plus 8 square, that is 64. So the answer here is 11,664. The next one is 135 whole square. Now we know how to find out squares of numbers ending with 5. The answer will be ending with 25. And the remaining part of the answer here is 13 into the next higher integer. That is 13 into 14. 13 into 14 is 182. So this becomes 18225. And the last one, 196 square. Now 196 square is really a large number. But then if you can take the base as 200, finding out square becomes easy. So 196 should be taken as 200 minus 4 whole square. 200 minus 4 whole square. So 200 square, that will be the first term. 200 square is 40,000. Now remember, because we are taking the base as 200, x should be multiplied with 4. When the base is 50, we take x into 100. When the base is 100, we take 2x into 100. Base is 150, 3x into 100. So when the base is 200, it should be taken as 4x into 100. So minus 4 should be taken 4 times. Minus 4 into 4, minus 16. Minus 1600. So the first term is 40,000. Second term is minus 1600. This gives us 38,400. 38,400 plus 4 square, that is 16. So the answer here will be 38,416. So friends, as you can see here, if you really understand the concept of how to take base and find out the required terms, then finding out squares of even larger numbers is a very simple job. We need not write anything on paper except the answer. So practice well on this and make sure that you are very good in finding out squares.